Good morning everyone. Thank you for joining us to this presentation. The subject is dedicated to SNCF rail maintenance and especially focused about BIM and GIS connection. If you enjoy the content, please do not hesitate to use the hashtag enclosed below on social media. We will start by just few words about speakers.
Hi everyone, I'm Béranger Marquez. I'm from SNCF Réseau. I graduated 1 year ago from an engineering school in Paris through apprenticeships, and then I became an entrepreneur due to an internal partnership between my company and Pathfinder.
My name is Quentin Marquette and I am a former Autodesk employee. I started this project with the consulting division and I am now available for another mission as a freelance.
So, SNCF Réseau is a service provider whose function is to manage railway infrastructure in France. It represents more than 15,000 passenger trains per day, more than 1,600 worksites each year. It carries out complex modernization operations and guarantees passenger safety. It also represents 5 million passengers per day in France, and 70% of it is in the Greater Paris region. We can notice a 40% increase in the traffic over the last decade. So, maintenance engineers have different tools to monitor permanent way states, and these are no longer adapted to them. So the idea is to produce a digital model for each geographical area, which will take up all the permanent way asset features. So there is 4 main goals within the project. The first one is to visualize the project area. It is sometimes tedious for a site manager to understand his monitoring area during his onboarding assignment, and having a 3-dimensional model representing the real-world context and highlighting vigilant points is mandatory to support the internal corporate workforce turnover. Indeed, a proximity manager position has an average of 3 years duration and is not unusual for a new employee to need several months to get ready and ensure the local management. The next goal is to monitor the infrastructure current house-built state and to cross data more easily. Keep track of permanent way routes requires to monitor a set of parameters found in various databases. It is sometimes tedious to search each information in each respective database. The new model makes it possible to federate information in the same place and thus drastically limit our research time. The third point is redirection linked to relevant specific application. Each SNCF business tool has a specific purpose and the model implemented must not replace it. The aim is only to federate data. Using this traditional tool will remain to perform and achieve an action and not for any data monitoring. In doing it, the hub model allows to redirect users to each online application. If you click on a rail default symbol, a link appears allowing you to switch to the business application. And the last point is to filter intuitively the technical documentation. SNCF is a company having a large regulation documentation, and it is sometimes difficult to understand and trace standards. The aim to filter documentation through the model improves information accessibility for maintenance team. When the user clicks on a component, rail, sleepers, ballast, etc., a web link gives access to the related internal documentation. Another important part of this project is to improve procurement process. When a new proximity manager starts his current position, the journey to perform his duties seems tricky. Each permanent way area has its own particularities, and it is sometimes difficult to remember all technical details during the first few months spent in the monitoring agency. Implementing a 3-dimensional model makes possible to visualize and learn much more and faster about the geographical area to lead. The proximity manager can see at a glance all default sections, list an inventory, or have data related to the track equipment. For Paris sub-region, users who could potentially be involved by the digital model utilization are around 120 agents in the monitoring office. For field workers with a tablet on site, the number of potential users is estimated between 500 and 1,000 people, still in Paris and depending on the regeneration operation, using ArcGIS Online as common data environment. The main objective is to implement in France the solution in 24 monitoring regional centers, and it could impact the daily jobs of over 6,000 users.
With the subsidiary Altametris, SNCF is able to capture the reality using LiDAR aerial surveys. They have several kinds of acquisition services, train captures, static laser scanners, and also drone devices. The point clouds used for this project were downloaded from the dedicated internal portal and are updated each 6 months. The model authoring design phase is completed using Autodesk Civil 3D and InfraWorks. The project scope is focused about a principal set of tracks composed of 8 corridors, train station, canopies, underground structure and maintenance building. Then, the client decided also to model the east and west auxiliaries set of tracks to have an overview of the site. One important issue is to take in consideration huge number of turnouts. For this, we use the rail module available since the 19.1 release of Civil 3D. The principal tracks and underground structure are designed with traditional process: alignment design, vertical design, customized Picatinny with subassembly composer and corridor creation. Please notice, we decided to split rail subassembly, sleeper subassembly, and ballast subassembly to allow several region lengths per component. Auxiliary tracks are just for visualization. We dropped 2D centerline on thin surfaces to convert it as feature lines. Then we applied the standard rail subassembly to create the east and west set of tracks. For train station platforms, we use customized Picatinny with target mapping to follow LiDAR aerial survey and deck feature lines. Bridges are created using the great preliminary function of InfraWorks. Unfortunately, for the maintenance building and also the 2 passenger buildings, Revit models were not forwarded by the architect. Of course, to simplify our Civil 3D processes, we used also local data shortcuts.
So, concerning the database asset management, each tool used by SNCF handled only one type of data. Excel spreadsheets were exported regularly by robots to be reused in DynamoScript. The type of information were the rail defect, the defect in track geometry, expansion joints, glued insulated joints, turnouts, and track equipment. DefRail is a database related to rail defect. Internal tools allow to have a census of track rail defect according to a codification. The defect inventory is based on geographical location and by gravity. Each defect has comments enclosed in a folder. The objective of the rail monitoring are minimize the occurrence of events reducing the passenger safety and to visualize the state of permanent way assets in order to make the best decision among the different options offered by the maintenance policy. GeoVois database is a database related to defect in track geometry. All defects in track geometry are listed in a document accessible online, and the defects are ranked following their station, the considered track ID, and also following other parameters, allowing their codification. GeoVois is an internal tool and a critical pillar of permanent way monitoring. AD database is related to the expansion joints. This database is actually an extract from a more complex database. Initially, this data must not be incorporated into the digital model, but things changed to put the concept forward. Expansion joints are rarely moved or renewed on site. The data does not have the same codification following geographical districts, so the aim was to spotlight critical data to bring feedback and use robots in the future to define and automate the adopted, simplified database layout. The JIG database is related to glued insulated joints. The glued insulated joints stop the electrical continuity in the continuous welded rail. This spreadsheet is a local district expectation to include in this proof of concept. An equipment inventory was created by the maintenance team and they required to implement it in the digital model. The aim is to spotlight the possibility to include additional local data in the process, even if it's not necessarily included in national database. District and permanent way areas could differ a lot following the geographical region. There are standardization needs within the SNCF group, and starting from a local expectation about a technical topic can improve the national data census. Moreover, aligning these topics can only improve trackability and monitoring itineraries qualities. ADV database is related to turnouts. A turnout is a device ensuring the track continuity for a chosen itinerary between the main track or a diverted track. There are 2 types of device: point switch or diamond crossing. The point switch turnout is a track device that allows a rolling stock circulation following 2 or more itineraries having a common branch, and the diamond crossing is a track device allowing rolling stock circulation between 2 intersecting tracks. As previous expansion joint database, this one is also coming from a more complex database. Ad hoc spreadsheet layout was thought for this proof of concept requirement. In the future, robots will define and automate the adopted simplified database layout. The main difference for the turnouts database is the amount of data, more important than other databases. And we had to check the readability was not jeopardized by the completeness of the information. So, Plancher National database, which is related to track equipment, is also coming from a much complex database. And from this database is exported this following data in multiple files: ballast data, sleepers data, and rail data. So, about the ballast section. The ballast is the material ensuring the transmission and the distribution of the strength applied to the rolling stock on the track subgrade. The ballast is an essential component. Sleepers are what rail are laid on, and concrete sleepers are longer sustainability than timber sleepers, and their heavier weight ensures a better track stability. There are two types of concrete sleepers: the twin block concrete or the pre-stressed or reinforced concrete. Concerning the rail section, they must support the rolling stock trench and ensuring the wagon guidance. The vinyl section profile is the only one still manufactured for the French rail network. The profile is very easy to roll due to a symmetrical and balanced shape. So, the object libraries have been designed for future data utilization and to anticipate the BIM-GIS connection. Some components have been created especially for this proof of concept, other was already used previously for other projects. So as you can see, some POI were made with Autodesk Inventor, such as the glued insulated joint, the turnout point of interest, which is not a track device, but a thimble that is laying on top of the track. The timber sleepers, some have been made with Autodesk Fusion 360. The expansion joints, the rail effects, and defect in track geometry. Only the concrete sleeper are actually native CAD 3D solids coming from existing datasets.
The first step of design automation is to create one property set per category. As you can see, the number of attributes is various. The most challenging part for us were the turnouts. SNCF Réseau is waiting a lot about data to maintain this device on site, around 35 attributes. Then, Dynamo for Civil 3D permits to fill the property set fields implemented previously. We are reading the spreadsheet export created by robots. Following the geometry complexity of the block reference to place in the model, we decided to create several kinds of scripts. Some of them implement POI directly for all the tracks, and some others are dedicated to one particular track.
For the next step, we need to move toward Navisworks to build the federated model. Navisworks is a model that made possible to facilitate the navigation in the different permanent way areas, and the model owner, the BIM coordinator, will use Navisworks managed license to carry out daily exports to agents who will use the Navisworks Freedom licenses. For data aggregation, the sources appended in Navisworks are 3D solid exports and not the initial model altering file with the corridor. Some AutoCAD Map 3D functions were used to filter and reproject some content in other drawings and prepare the BIM-GIS connection. Thanks to the aggregation, it is now possible for every manager to see every constituent in the area. The data consultation is now possible with the custom property sets data added with Dynamo, and it is reachable from the property windows anchor on the right. This aspect is without a doubt one of the most important of the project, because it now allows the managers to not waste time searching information from business application to business application. As explained earlier in this document, one of the most important points for a proximity manager is the internal corporate workforce turnover. Manager and technician are only allowed to stay 3 years at the same geographical job position. Each 3 years, another employee is coming to fill the position. The time to be comfortable with the internal tool can reach up to 12 months, and this is in particular due to the infrequent utilization for some of it. This brings a tedious aspect for some tasks, and also because tools are not centralized. So we can say that the human workforce is not at its full potential and over a substantial part of their job position duration. It must be found a way to smooth the HR turnover and relieve the end of knowledge process. These improvements are essential to make easier and optimize the employee working time. Another important point is to limit the time required for data consulting and to schedule maintenance tasks. Proximity manager must spend more time on site with the teams. This job is one of the first positions in manager ranking. Employee must develop technical skills because the opportunity still below it. This expertise will follow them during all their career path, and this first position consolidates the knowledge base. It seemed logical that spending less time to schedule and monitor processes allows to spend more time for the staff management. It should necessarily lead to a more qualitative team management, and therefore increasing skill for agents and district division. This set of improvements must therefore benefit to monitor network sustainability.
Autodesk Civil 3D and ArcGIS Pro do not have exactly the same behavior. Civil 3D model authoring is composed of 3D solid exported from the corridor designs, or directly use block reference implemented with Dynamo. ArcGIS Pro use multi-patch feature class for volumetric entities. It's difficult to link each component from BIM to GIS. Despite the partnership between the two software corporations, the Autodesk connector for ArcGIS do not allow to export linear design directly. And when we worked on the project, the 2.6 release of ArcGIS Pro was not still available. Now it's allowed to read directly DWG files, but not to understand correctly each component. When you do not have a native connection between BIM and GIS, it is more difficult to fix the issue. It seems a little bit more complex, but not impossible in fact. To achieve the workflow, we use a magic tool named FME. FME is an acronym of Feature Manipulation Engine and is released by Ceph Software, a Canadian company. Maybe some of you know the product as Data Interoperability for ArcGIS. The tool is an ETL, extract, transform and load, allowing to transcribe, in our case, DWG file to geodatabase file format. Of course, we are keeping the geometry and all the data implemented in the property set. The data is now in 3D GIS attribute tables. Just check by yourself on the picture below. The next expectation for SNCF Réseau is now to bring the model on site. How could we complete this without InfraWorks mobile app or BIM 360 as default common data environment? The choice was made to use ArcGIS Online with corporate tablets. Unfortunately, it is not possible to export directly the ArcGIS Pro model to ArcGIS Online. The platform uses a WebGL technology to display the content and need to complete before some processings. We have two kinds of data in our model, points clouds and 3D object. To export it, we need to launch function to convert it as scene layer packages, also named SLPK. Each SLPK files must be uploaded after on ArcGIS Online to rebuild the 3D scene on the cloud. Only after this you can use it from your account panel with a tablet on site. The synthesis workflow is now displayed on the screen. We invite you to take a screenshot to interpret it after. Please notice we do not investigate yet on how modify data on site using ArcGIS Online.
So ArcGIS Online is a WebGIS platform allowing connection to real-time data flow through API and web services. The tool can become a customized data aggregator and be linked to BIM 360. It also can be either in the office premises or on a tablet touchscreen on site.
The project was named initially to the Golden BIM Award in the Operation and Maintenance category. This ceremony rewards the best project in France or completed overseas by French-speaking company. This year was a little bit strange for us. Mask, new reward site, and the jury switched at the last time the project to another category. All are apologize for Arcadis, Bureau Veritas, and Gare Connexion about this misunderstanding and why we switched to infrastructure category.
So we also would like to announce you that we are going to have a class in the Autodesk University Digital Edition. It will be a 1-hour movie and it will be delivered with a detailed technical handout of 100 pages.
And we will also be present to SIG 2020, a French live web conference organized by us3. For French customers, see you the Monday 12th of October.
So I really would like to thank you for your attention. It's been a real pleasure.
So thank you for your presence and do not hesitate to contact us for any additional information.